Hello, today we are going to take a look at the Bestek 300 watt pure sine wave power inverter. And what this device does will convert 12 volts into 110, 120. So you can run household items, small household items off of this while this is plugged into your vehicle via a cigarette lighter adapter. So what I'd like to talk about first of all is most vehicles, or modern vehicles I should say, will not give us the amperage that it's going to take to get a full 300 watts out of here. Modern vehicle wiring that's going to the accessory leads or cigarette lighter plug, as we used to call them in the old days, is a thin gauge wire, usually around 16 to 18 gauge wire. What does that mean? It's not going to handle a lot of current draw, and this will draw a lot of current. So what I did is I kind of mocked up a real world scenario here. I cheated a little bit because I'm using a little bit thicker gauge wire. I'm running 12 gauge wire. I have a 10 amp fuse in here. I'm running my LiPo 4 battery, which is at about 83% charge, I think, at this point. And what I want to show you is what you can run off of this in your vehicle safely. Now, a lot of modern vehicles are fused, or I should say that accessory lead is fused at 10 or 15 amps. Okay, so we're not going to want to go over that, because if you start going over that, if you don't pop your fuse, you're going to at least be heating up your wiring in your car, and on that circuit, I should say, and you don't really want to do that, not for a very long period of time. So what I have here is I have this mocked up like it would be in a car. I have an amp meter on here. I have a voltmeter right there. And we're just going to power up stuff that I think the average car camper would want to do. So I've got my laptop going here, and we have the laptop charger. I have a CPAP going here, and then a small little fan. I think, just the perfect size to put in a vehicle. So let's just say you want to charge up maybe a tablet or a cell phone, but we're going to use a tablet for this demonstration. This is the AC adapter for the CPAP. This is the charger for the laptop. And I am going to use my CPAP with the humidifier on and the tube heater on. And the reason why I'm going to do that is because that's going to pull the most current. All right, so we're going to kind of see what this thing tops out at as far as staying under that or around that 10 to 15 amp limit for what your car is going to be able to provide to the inverter. Okay, we got a little watt meter here so we can check things out. So I'm going to get this thing set up, and we'll get started here. Okay, so I just got through setting up the CPAP. We have the fan on, we have our device charging, and the laptop is charging. And we are pulling 138 watts, so almost half of what this is rated at. And as you can see, look where we're at here for current draw. We're drawing just about 14 amps. And a fuse is not getting warm yet. Now this is going to settle down a little bit here because, when you first plug the laptop charger in, that's going to have a really high current drain until it kind of levels out. The same thing with the CPAP. So now we're kind of down here to 100 watts, and we're coming in at just under that 10 amps. Okay. So, I think if you're parked, you're just getting into camp or wherever you're at, your destination, I think this is what you could safely run. You could set up your CPAP. You could maybe cool down the vehicle or whatever with the fan. You could maybe start charging your device and all of that. I wouldn't really recommend running this for a long period of time. Now, if you got like an old 60s or 70s car, old Riviera Camaro or something, you can do this because those accessory circuits, if I remember correctly, they were fused at about 20 amps because the old school cigarette lighters, which was really originally what this connection was designed for, they pulled a lot of current. So my meter just shut down here. So let's turn her back on. The inverter here, the fan has not started yet. This is just barely above room temperature. Now I've been running this system while I've been setting all this up for demonstration and everything. I've been running this pretty hard. And it's looking good. All right, so let me explain something here. I'm running this off of this LiPo4 battery. If you have made a little to-go pack or something like this, this is the perfect demonstration here. But what I wanted to show you was operating voltage. Most 12-volt automotive batteries are going to be around 12.4. If it's lower than 12.4, you have a bad battery. All right, or you have one on the way out. But anyway, this is going to be about your average operating voltage, depending on the vehicle. 12.4, just under 13. Of course, while you're driving, it's going to be, average around 14.4, something like that. And this is rated for, I believe it was 17 or 19 volts. Apparently, Tesla outlets provide more voltage. I did not know that, but anyway, there you go. We're running real world 12 volts, about 94 watts, and as you can see, we're starting to settle down a little bit, about 8.5 amps as this thing starts charging up. Now, when this thing ramps up in real use, it's going to pull a little bit more current. However, it's going to be up down as you breathe. So it's not going to be taxing it at just one continuous rate here. So again, we're at 8 amps. And the fuse harness here, remember this is a 10 amp fuse in there. It is now just above room temperature. It was cold when I started, so it's just above room temperature. The fan has kicked on this, and we're still doing pretty good. Where are we at here? Yeah, see, this hasn't ramped up because I'm actually not using it, breathing through it, and the ramp pressure will go up considerably, and that will draw a little bit more current, probably taking us back up to this 10 amps. Okay, so I'm pretty happy with that. Let's see here. What can we do? Let's take the computer charger. Let's just say our laptop's charged. Take that out of the equation. Now our CPAP and our fan and the device, we're down to 5 amps. Let's unplug the device. That charger's getting warm, so I know we've been putting a good charge on that tablet. Now we're down to 4 amps. Now this is, using these are great, but it's not the most efficient way to do things. But yeah, I mean, this is just, the fuse is warmer than this, okay? So we're down to just under 47 watts of current. Can you see what I'm talking about here? This is rated at 300. We used half of that, and we had a high amperage. In fact, we were taking our vehicle wiring to the absolute limit here, okay? But let's just say we want to run a fan in the car, just for the heck of it. Let's turn the CPAP off. Okay. So now we're just running the fan. Let's just put this in. Let me just unplug that because the PAP isn't running right. There we go. Okay, so now we are at about 42 watts. We've got that high first initial charge on the device, and we're at 4 amps. Let's take the device off. So if you were sitting like at a rest stop or something, and you wanted to, put a charge on your device and maybe charge your laptop or whatever, not a problem. Okay, so now just using the little fan, we're at 3 amps. And we still have a real world voltage there. Now, as that voltage drops, this current draw will come up a little bit as well. All right, now let's talk about the device, or the inverter itself. As we have demonstrated in a real world situation, just under half of the rated power output of this takes us to pretty much the maximum current draw we're going to be able to use off a cigarette lighter or an accessories outlet, okay? So if you want to get the full 300 watts output from this, you are going to have to wire directly to the battery of your vehicle. So you're going to want to take like a piece of, I would actually use 8 gauge. You're going to want to go with 8 gauge from the cockpit of your vehicle straight to your battery. I fuse my batteries as close to the battery terminal as you can get. Never go more than about 6 to 8 inches. You always want it right real close, okay? And then you can pull a chassis ground. If you want to run another ground wire from your battery, you can do that, but I would just do a chassis ground, a nice piece of 8 gauge wire. Go to your local car audio store, support your local guys. I'll leave a link down below for all this stuff anyway, but if you go to a car audio store, tell them you want to buy an amplifier installation kit, you'll get a really good fuse holder, and you'll get the proper wire in 8 gauge. It's always best to go over. If they try to tell you, oh, well, a piece of 10 gauge will work just fine, just go 8 gauge. You want bigger. The bigger, the better. All right? It'll keep this happy. You don't want this struggling to pull current or energy through the cord, right? And through that, 7 to 10 or 12 foot run that it's going to take to get from your car battery up to the cabin of your vehicle. All right, so all that being said, I like this. Something that's kind of interesting on this, even though the switch for the AC side of it is turned off, well, it's on now, but when you turn it off, you still have charging capability. You still have power coming out of these USB-A ports. So that works out really well. I'll take that out of line. Now that's showing like 1/10 of an amp, but that's just straight current here. So see, that's going to rise up. So anyway, that's kind of interesting. I don't remember seeing that in the instructions, but that's kind of cool. So basically, this on-off switch is turning off the AC side of this inverter. As long as you have this plugged in, you're going to have the circuit here live. And that's okay. I'm okay with that. Okay, the fan on the rear panel. Now on the unboxing, I just guessed, but I thought that this was drawing cold air in on this end and then exiting out the slight little vent action we have here and here. It is not. What it does is that fan is drawing cool air in from this end and exhausting it out here, which is probably why this fan's pretty quiet. This is a quiet running device. It has a great sine wave. My oscilloscope read 59.9 hertz, flickering to 60 hertz. So that is the proper frequency for this to be running at. And the sine wave was clean, very clean. The limitation to what this thing's going to do is by what you have it plugged into. So that's going to be the cigarette lighter circuit in your vehicle. And again, I cannot stress this anymore. You want to go over, say, 150 watts, you're going to need to directly wire to your battery. All right. So thanks for watching, everybody. Sorry about the lengthy video, but I like to be as thorough as I can to keep the questions down in the comment section. I do try to answer everybody's questions. And again, if you have questions or comments, leave them down below. I'll leave links down below for the watt meter, for the Bestek, which I like, for some test gear here. And yeah, anyway, thanks for watching, you guys. Appreciate it. And please don't forget to like and subscribe. Cheers.